If you're looking to deploy machine learning workloads or training a large language model or doing inference on a huge data set and you're worried about distributed computing and how are you going to manage lots of GPUs and CPUs and how would you do the distributed computing, then Ray can come to your rescue. Ray is a unified framework for scaling artificial intelligence and Python applications, especially in the context of generative AI. So Ray is primarily a simple unified framework designed to scale AI applications. Ray includes a core distributed runtime and specialized AI libraries for tasks like data handling, data manipulation, training, and hyperparameter tuning, among others. Ray also supports seamless scaling from a laptop to a cluster in a matter of minutes. Now, one great thing about Ray is that it is not just yet another AI project, it has a full blown philosophy behind it. Ray aims to provide a universal API for distributed computing. A core part of achieving this goal is to provide simple but general programming abstractions, letting the system do all the hard work. This philosophy is what makes it possible as a developer to use Ray with existing Python libraries and systems. A Ray programmer expresses their logic with a handful of Python primitives, while the system manages physical execution concerns such as parallelism and distributed memory. A Ray user only thinks about cluster management in terms of resources, while the system manages scheduling and auto-scaling based on these resource requests. Now in this video, I'm going to show you how you can install and play around with Ray, and I'll be using Ray Core for it. And similarly, you can use it for data, for training, for tuning, serving, RLib, and also for the custom applications. I'm going to use this Google Colab for this demo. You can use AWS SageMaker Notebook or even any other Linux instance. Let's get started. The first step is to install Ray, which is simple pip command, pip install -u Ray. Let's run it. And it doesn't take too long. It's very quick. That's done. In the second step, we are going to initialize Ray. And in the later versions of Ray, you don't even have to do this initialization explicitly. As soon as you run the first call of Ray API, it gets called automatically. Okay, it is just telling me that I already have run it, so you can ignore this one. Now, let me run a task with Ray. So you can see that in this one, I am using Ray, which is letting me run functions as remote tasks in the cluster. All I'm doing here is I'm decorating my functions with ray.remote like this, and which is telling it that I'm going to run this function remotely, and then I'm calling this function with dot remote, and then like this here instead of calling it normally, and then this remote call returns a future which is also called as ray object reference. Now let me run it so you can see that how quickly it has worked here. Now second concept in the ray code is called as actor. Let me show you how you can call the actor through the code, and all of these examples are from Ray's documentation. I will drop the link to that in video's description too. So in this one, you can see that I'm using Ray actor. Ray provides actors to allow you to parallelize computation across multiple actor instances. So when you are instantiating this class, that is a Ray actor, Ray will start a remote instance of that class in the cluster here. And then this sector can then execute remote method calls and maintain its own internal states. Let me run it. And there you go. It was very, very quick, even the distributed tasks. And then finally, we have this concept of object, which we already saw the object reference. So Ray stores tasks and actors called result in the distributed object stores, returning object references that can be later retrieved. And these object references can also be created explicitly via another command which is called as ray.put. Let me show you the code. This is the code to pass an object or generating an object reference. Let me run it. There you go. Now, these primitives are very simple, but when you combine them together, chain them to express any kind of distributed computation, as we saw in this GitHub repo, you can do a lot of things around it. And then in this GitHub repo, you can see that there are various use cases and examples for data, for distributed training, for tuning the hyperparameters, and then reinforcement learning with RLib, and also programmable serving with serve. And there are a lot of other things, and then these are the stuff which we just touched upon in this video. I hope that you enjoyed it. If you have any questions or concerns, or if you're already using Ray, please share your experience. And if you like the content, please consider subscribing to the channel. Thank you very much.